afternoon, everybody. It's great to be here. We're going to do a presentation on the VDURA transition. So VDURA's over 25 years old. I'm just going to move to the next slide. Okay, so Panasys has been through a history of innovation. Our journey began as Panasys. We're as I said, over 25 years old. We were founded by Garth Gibson, and for those in the room who know Garth Gibson, they also know he invented RAID, with the first Linux-based parallel file system. We've always focused on high-performance storage, introducing breakthrough like RAID 6 and triple parity, and transitioning to commodity hardware and flexibility. By 2020, Panasys 9.0 brought organizations like dynamic data placement and flash integration, setting the stage for the future. So in 2023, under new leadership with Ken Claffey as our new CEO, we refocused on AI and HPC as core markets. By 2024, we rebranded as VDURA, launched a SaaS subscription model, and expanded with over 50% new hires in engineering and also in development. We introduced version 11, which is the latest version of the parallel file system, a major software release, and built a robust hardware partner ecosystem to deliver the next generation solution. Looking forward now to 2025, 2026, VDURA is driving the future with an AI data platform starting with V11, metadata and flash performance delivering up to 6 million IOPS. We are rolling out cloud SaaS offering and introducing the All-Flash version 12 platform, designed for next-gen AI, HPC workloads. Our focus remains on channel and reseller partnerships, ensuring scalability and guaranteed data durability. So VDURA has built decades of trusted partnerships with industry leaders, demonstrating our ability to support the most demanding workloads. The feedback and collaboration from our partners directly influence our product innovations, ensuring we are building solutions, not just for today, but for the future of AI, HPC, and data-driven industries. AI and HPC might share similar infrastructure, but their workloads are fundamentally different. HPC applications, as we know, are CPU-centric and with some dependency on GPU. Workload characteristics are typically high-speed networks like InfiniBand and gigabit. They focus on write-intensive tasks like checkpoints, but mostly handle sequential workloads, so the data is processed in a certain order. They deal with large files, typically 100 gigabytes up to terabytes of data. Whereas if we look at AI applications, they're more GPU-centric, with some CPU support. AI usage rely heavily on GPUs and CPUs supporting secondary tasks. Workload characteristics are also InfiniBand and gigabit, but they're both write and read intensive, requiring storage. So they also handle a mix of file sizes, like very, very large files, hundreds of gigabits, but also very small files, like 4K files, but also handling a lot more, like billions of those types of files. The key differences between HPC and IO workloads is the users and the way the systems are configured. So HPC users typically work on large-scale clusters designed for traditional supercomputing tasks, whereas IO users, workstations and clusters are optimized for GPU-heavy tasks, like training and inference. So AI and HPC fundamentally different in how they use resources, the CPU versus the GPU, and in their data requirements require sequential versus random, large versus small files, and recognizing these differences is key to optimizing the infrastructure for each workload. Frequent checkpoints and AI workloads can negatively affect GPU utilization, as GPU sits idle during these checkpoint operations. What are checkpoints? In high-performance computing, checkpoints capture the memory state of a system and save it to non-volatile storage, like a safety save in a video game, for example. Checkpoints are critical to ensuring data is safe in case of failures, especially during long AI training cycles. The problems with checkpoints: frequent checkpoints are necessary for AI training, but interrupt GPU processing. GPUs have to pause while checkpoint data is written to storage. This tends to lead to idle GPUs, reducing efficiency and wasting valuable processing power. So why is storage performance, why is it important, and why does it matter? The faster the storage system can handle checkpoint writes, the less GPUs remain idle. Low latency during model runs is crucial. High throughput, so that's how much data can be written quickly. During checkpoint writes, minimize GPU downtime. The parallel file system solutions are designed to handle these high-demand storage requirements. They enable faster checkpoint processing. This ensures GPU spend more time running models with less time waiting. So efficient parallel file systems are essential for AI workloads to maximize GPU utilization and ensure smooth, uninterrupted training cycles. Investing in high-performance storage systems reduces latency and keeps GPUs running at peak efficiency. So introducing our next generation platform, VDURA V11, version 11, is purpose-built driven breakthrough performance for AI and HPC applications, setting a new standard in the industry. So we have superior performance. So this is with leading IOPS, metadata handling, and throughput performance. The version 11 ensures that even the most demanding workloads run seamlessly. This makes it ideal for AI training, real-time analysis, and high throughput simulations. Support value. The V11 offers a scalable hybrid architecture that balances the high performance with low cost. Unlike competitors, we contribute to the speed of flash storage with the cost efficiency of hard drives, delivering unmatched value, guaranteed durability. With the durability guarantee, we provide superior data protection, ensures peace of mind for your critical workloads. Our advanced architecture ensures your data is safe, no matter the scale or complexity of the system. Version 11 is the next step in redefining storage for AI and HPC, offering a perfect blend of performance, value, durability to meet the needs of today's data-intensive workloads. And now I'm going to hand it over to Sven to talk about some of that technology.
Good afternoon, everybody. My name is Sven Erding, Solution Architect for VDURA. Let's dive some deeper into the VDURA architecture. Two constructs, we have VLOS, VPODs. VLOS is purely flash-based, latency optimized, throughput optimized, but it's based on a distributed key value store where we want to reduce really the latency. We use it mainly for metadata. As we have seen, the transition from HPC to AI, lots of small files, metadata requirements become more and more important. That's why we have transitioned to a distributed key value store purely flash-based. The other thing is the VPODs. VPODs is where the bulk of the data are stored. We either have hybrids with lots of hard drives and flash, or a pure flash VPODs. Our VPODs will also do compression inside it, and we also have an optional extra erasure coding inside the VPOD. So how does the PenFS file system work? So while PenFS has transitioned to VDURA, it's still our old PenFS file system. We have Linux compute clients. We have our own protocol, direct flow, for parallel access to the data, but while at the same time supporting NFS, BNFS, S3. Rely on a network to connect to the storage. It's either Ethernet or InfiniBand. If there is a demand for Omnipath, we also would support Omnipath. On the bottom, we see the storage nodes, vPods. As I said, we either have hybrid storage nodes like flash and a lot of hard drives, or pure flash storage nodes. And then we have the VLOS. VLOS is purely flash. As I said, inside the distributed key value store, meaning we can scale on metadata performance just by adding VLOS. The way we do our data protection is different from most other file systems. We're doing the erasure coding inside Linux client, meaning that your data is already protected when it leaves the Linux client. So even if you have like corruption inside the PCI bus, inside the network, or when arriving on the storage node, your data is already protected. The fact that we're doing the erasure coding over the network also means that we scale in performance for reconstruction. The bigger the system gets, the faster we reconstruct. Erasure coding is also flexible. We can choose it on a per volume, per directory, per file basis. This gives you a lot of advantages. It gives you, we can guarantee you some kind of durability, because like the smaller your erasure coding, the faster we will reconstruct. So depending on your needs for how durable the data needs to be, we can size the system for you. As I said before, inside the storage nodes, we also have the optional erasure coding. So we do multi-level erasure coding, and the combination of the network erasure coding versus the local erasure coding inside the storage nodes really gets you a really durable data system, unseen in the HPC and AI world. So usually we provide hybrid systems, meaning storage nodes with drives and flash, and then also flash nodes. And depending on the user requirements and the budget of the customer, we can choose, okay, how much flash you need in the system, from like a lot of hard drives, tiny amount of flash, to if you want to all flash. It just depends on the amount of how many performance, how many throughput, what are your requirements for availability and durability. And we can size the system as you want. This is also a flexible, meaning AI workloads can be unpredictable. You can size your system for today, but you don't know what's going to happen next year. In a NFS file system, if you need more IOPS, we can add flash nodes. If you need more throughput, more capacity, you can add more hybrid nodes. All of that in a single namespace with a policy engine which moves the data around.
So just adding to what Sven said, that we're very much following the hyperscaler strategy. So if you look at independent survey reports on the big hyperscalers, you'll find, depending on how efficient they are, they vary between, say, 20% flash versus 80% disk. Some very efficient hyperscalers have maybe between 5 and 7% flash, and sort of 85%. So we're very much following that. So we've adapted our sort of solution model to the customer, so we can actually mix the amount of flash drive to hard drive as required. So it's a very flexible model. Okay, so as VDURA, we call this the VDURA 5000. As a leading industry hybrid appliance, right? So what are some of the performance highlights? Again, IOPS performance, we're up to 2 million IOPS per director. So that's, 3 directors in a system, 6 million IOPS. So we're definitely, pushing up there in terms of performance. In terms of throughput, we're around 200 gigabits per second. We have density, so we can, with the new technology we have now, we can actually fit up to 26 petabytes of usable data in a rack. We have advanced data services, so we have things like Some of the features include quotas. We've got data reduction and encryption for optimized storage and data security, with multi-protocol support. Seamlessly integrates with protocols like direct flow, NFS, SMB, and S3 for flexibility. So in terms of reliability and production, so this is where when we say following the hyperscaler strategy, we're able to sign an SLA with a customer for between 5 to 11 nines and durability. In terms of sounds already covered multi-level erasure coding, protects the data, both at client and at node level. The VDURA guarantee ensures top-tier durability and availability during the standard in data protection. And in terms of the ease of use, cost efficiency, we have enterprise usability. Simplifies operations for both small teams and large organizations. The cost optimization uses hyperscaler-focused devices to deliver optimal cost to performance ratios. So the VDURA 5000 hybrid appliance is designed to deliver top-tier performance, scalability, and reliability while maintaining ease of use and cost efficiency, making it perfect choice for modern AI and HPC workloads. So in terms of hybrid architecture, VDURA delivers the best of both worlds by combining the speed of the SSDs with the cost savings of hard drives, of HDDs, ensuring top performance at lower tier. Our performance, in terms of HPC and AI ready, our platform is designed to handle the most demanding AI and HPC workloads with features like dynamic data acceleration, multi-level erasure coding, as Sven's mentioned, for unmatched durability, and adaptive capacity balancing for scalability. Also, flexible deployment. VDURA works seamlessly across on-prem cloud and hybrid environments, giving the flexibility to adapt to your infrastructure needs. Simple management, a unified management protocol. Unified management protocol reduces IT overhead. So for those of you who have limited resource, it's relatively easy to manage, or less overhead in terms of resource. And it's easy to configure, monitor, and scale. VDURA delivers best-in-class price performance, ensuring you maximize without value compromise, without compromising durability and performance. VDURA is the ultimate solution for organizations looking to balance performance, scalability, durability, and cost efficiency. With our hybrid architecture and advanced features, we're redefining what's possible for modern data platforms. There's the man himself giving the guarantee. So I don't know if anybody has any questions now. We're happy to take questions, or we'll be at the booth, time permitting.
Any questions?